How's it going, everyone? Welcome. Julian Gonzalez here. Today we're gonna take a look at the catching dependencies, which is one of the things that we can do, especially by defining these workflows to set up a continuous integration, continuous delivery process as a way to make our enterprise UI development with this big code bases that we need to maintain over a long period of time with a wide range of contributors much more easy. And in this course, which is taught by Steve Kinney, shout out to Steve Kinney, head front-end engineer at Temporal, where the idea of this is to see what are the things that we need to put in place, what is the infrastructure needed to make this enterprise UI development easy to work with and maintainable over a long period of time with a wide range of contributors. So, because we're gonna jump straight forward to this particular segment to make sense of how do we get here, just briefly describing that when it comes to understand what are the things that make this that make this that make this enterprise UI development maintainable, we need to understand is what are the systems that we need to put in place, then the process, and then the patterns. So the systems start with, hey, we need a testing system as well as a build system and also a static analysis system. Then we're going to now implement is the process that we need to, or the know-how. This is how to do the things. For example, document designs, code review, and as we do this kind of process, this how-to, we a lot of the time encountering is particularly repetitive things or recurring things that happen, which is, well, how we're going to set up our architecture, how we're going to maintain the state of our application in the UI context, and also how we're going to abstract things, how we're going to modularize things in a way that actually is making it much more easy to maintain that, right? So abstraction, state management, architecture. So we look at the unit testing. What are the unit testings? What is the spectrum of unit testings? The tools that we're going to use in this course, which is with Vite and the React TypeScript Vite testing library for UI development, for component testing, and the E2E, which is the end-to-end test, right? So first we started to look at unit testing. How can we, so some of the concept, the definition, and the jargon that we need to know. So for example, like assertion, test, and test suites. A more practical approach of how can we writing our tests. Where is the greatest hits? You can say that when it comes to work with this particular test. As you write your test, what are the things that you want to most of the time test? Whether it is referential equality or value equality. Also, you want to check is for numbers and their decimal points. For example, to be close, you want to check is two objects are the same or they have the same instance, the instance of. You want to check if this element actually are contained in an array, or if a string or a subset or a small set of string actually contained in a large string. The same for you want to check a subset of properties in an object or in an array if that exists, or if you want to check the type, okay? And some more advanced topic, especially when handling is asynchronicity, this concurrency that happens. and how can we handle that? For example, using a saying and a wait, or reject, or promise. And also when it comes to tests, our when we write our test for synchronicity, especially for throwing errors in the functions, how we can also have some of this method that allows to check that that actually works expected. And okay, uh, and uh, sorry, and then how can we now make all of our tests that we write deployable and deploy that as a way to make this code integration and delivery and deployment much more easy. So we look at this CI/CD process. I know we're not dive into that, and all of the different phases, and how now before that we have something called Jenkins. That I don't think Jenkins. I don't think a lot of people actually have a very good experience with that. This is for Java applications, okay? And working with Java can be very quite challenging, okay? But the whole point of this is to now allow to automate that the process of integration, co-integration, and delivery, right? Which is useful and important for Java applications. Imagine that. Just imagine that. Okay. And then how now things come up after that. So for example, like Ansible is one of them. But here now you can control is servers, right? Again, there's some other tools that allow us to do these kind of things for this specific use case. And we use now is GitHub Actions as a way to actually is implement that. We also have Travis CI, right? Which is all of this particular tools aims for the same thing, is to make now the continuous integration, continuous delivery much more easy to work with. So that's why we have things like GitLab that provides something called as flows, and this is something this is interesting. Why it's not here? That's interesting. Yep, that's very interesting. That's very interesting. Okay, completely. Yep, that's very interesting. Anyway, well, but right now we are using is GitHub, right? So this is the thing that we are actually explore the GitHub, especially the GitHub Actions and the workflow, which allow us to automate this process of continuous integration, continuous delivery by any time we now is, for example, which is most common use cases, anytime anytime someone integrate code, anytime someone make a PR, we can run the build and test before actually merging to this code, or any change added to this PR, we can actually run that. That's great. Also, we can is on any new release, we can put a tag on that, or you can is on any issue created, you can put a tag on that. There are also some other things that you can automate. So for example, when you want to trigger now a webhook into another place, usually for Updating is npm. Updating is an open source to npm registry, or to generating a new release and then deploy that on the AWS, Amazon's cloud servers, or Azure, or any of these other any of this cloud service provider. So, and as we look at this workflow and how that works and the anatomy of this, which is the events and the jobs, and the job is made of steps, and these steps can be bash scripts or custom actions, GitHub Actions, and this GitHub Actions is just a way of how you can reuse some of these complex tasks and repetitive that you need to do, such as setting up a build tool for your build environment, or setting up an authentication process for any cloud provider, or clone a repo into these CI/CD servers, okay? And then how each one of those bash scripts are running on a runner that is provided by GitHub, which is this virtual machine that has now that they can give it to you, whether it's like an Ubuntu, Windows, or Mac, okay? And then as you write now your different jobs to cover those particular use case, when you want to speed up things, that's when we started to use these catching dependencies, right? Because most of the time, especially when we are integrating our code, we want that particular phase go smooth and fast as possible. Sorry. Let me get some water here. I'll be right back. All right. All right. Awesome. Way much more better. Good. And how, by the time we look at how can we create now this CI/CD process using the Git workflow, and how can we now set up things like Git branch protection as a way to prevent some new developers, or even myself, to actually do some stupid things like merge these changes quickly without any checking status, or without letting others to approve my change, for example. And once we get in here, this is now another area of responsibility that is the sorry, Jesus, my bad. That is part of the software development, which is now IT security, trust, IT security and trust, right? Where here again, this is something that go beyond the scope of this course. Okay, so for example, here, this is now here security and compliance. You can say IT security and compliance. Okay, what we briefly describe is what are the challenge of maintain the security and compliance for these systems. And it is very industry dependent, but when it comes to understand now the challenge right now in terms of security, we looked at, we have two models, right? Back in the old days, we have something called like the castle and moat. I'm not gonna dive deep into that, just to mention that that particular model has the philosophy of the risk can happen outside of that, but once they cross the moat, well, you just lose the battle. So they can now get in, access the system, they can exploit system security vulnerabilities, they can steal credentials, perform social engineering attacks, inject malware. So this now zero trust security model, which was designed and coined and investigated and researched by one of the analysts at Gartner, they come out here now with this philosophy where say, hey, you know what? Instead of actually assuming that the risk can happen only outside, it also can happen inside, right? So there have now several principles here that they go along with. So for example, continuous checking, continuous validation, okay? The principle of least privilege, and continuously monitoring devices. So if an attacker is getting here and trying to move one place to another, let's go to now segmentate these areas of research. You can think of this as like little houses, right? The house, the tavern, and all the things that live inside of a castle, right? Or in this case, inside of the business. All of these different network areas where you have now research. And how, by understanding is that these attackers can move in one network to another. So by preventing this lateral movement, by asking for this multi-factor authentication, a lot of the time it seems to mitigate this kind of thing. And this is just a component of this thing called SASE, right? Which is not a spicy thing, okay? So SASE. It is, in fact, is an architecture to so it's an architecture that combine is the network security with network access. Why is this? Because now with the compelling cost of cloud computers, and a lot of these cloud service providers are being very good at offering is this hosting solutions as well as security. And now with the workforce distributed across the world, and we have now become much more effective at a distance. So these particular organizations now demand that we need to have is a certain security policies here, right? And that is, well, this SASE, or this security access service edge. Okay, so this is this particular architecture that is made of the zero trust network security or the secure web gateway as a way to actually unpack, look at the inside of the package, and then repackage that, or decrypt, look at it, encrypt, send it again. All right. Also, we have is this security access service broker. No, but this is a cloud access security broker, which is pretty much like a private firms. It's like security private firms where they offer a set of services, foot patrol, foot patrol, surveillance, verifications, But in this context, is now they provide is things like single sign-on, tokenizations, authorizations, as well as backup, data persistency, all of this service that they provide, and the software as a one. That to me is something interesting, or one as a service that this particular service can run in this network. Anything outside of that, no. And the next generation firewall. This is just to describe the security as well as the compliance that most of this company needs to follow. Okay, whether it is the SOC for the TLDR is for trust. Hey, are you guys, girls, pal, whoever is behind this, you are providing is this service that actually is on the consumer interest, so they are not going to harm them. Okay, so that's what you have now, the SOC too. And also you have now the ISO 9001 for quality management service, ISO IC 27001, which is for information security management systems. In the case of payment industry, you have now the PCI DDS, payment card industry, data protection, data security and standards, among other specific among other industry among other industry specific compliance. You have IPA, EBAN, BANG, and others. This is just to briefly describe here how do we get here, all right, especially when we need to actually add some sort of policy, some sort of control or branch protections here. And as a way to speed up this particular workflow, anytime we actually have to is integrate our code, all right, we can now is save some of those resources that barely change, and then run or build and test. And most of the time they are dependencies. So catching workflow dependencies, as I mentioned here, catching dependency to speed up workflow. So this is briefly summarized into things, right? So in the case of catching, you can say you can now catch dependency and catch artifacts. And the subtle difference is that things that barely change, okay, they don't often change between workflows. That's going to now catch that. Usually dependency. And the other is that anytime that a workflow output something, okay, or produce a file, you will like now to actually save that for that. Usually in generating the usually generating is the binaries or build logs. Interesting. And this is when we look at storing and sharing data from workflows, okay, and how now by the time you create when you create a workflow here or a catching, this only works is at the branch level, right? And any of all of this subchild branch. So sibling branch, they cannot share that similar branch or siblings branch, they cannot share that, which is good, which is great. And yeah. Comparing artifacts and dependency catching. Upon loading, build a test artifact. Exactly. So slowly but progressively understand that. And what we're gonna do is to recap this particular section, which is catching dependency to speed up the development. So let's get into this. This was quite interesting. It was definitely quite interesting because there are several concepts down there. Man, the best thing that I can do to my life is to invest in this knowledge. That's the best asset that I can. Unfortunately, you talk a lot.
There are some. I'll just call out some of the nuances right now, which is GitHub allows you to store stuff in two ways. We're going to talk about both of them today. One is caching, and the other one is artifacts. Artifacts are like things that you might.
So we can take a look at this. Exactly. So GitHub provides two ways to storing things that are specific use case. So for caching and artifacts, right? This is the general way of doing this.
One after the build process.
Okay, so this is speed up workflows for catching. Speed up workflow with catching. With catching dependencies. Okay. This is it. And this is the general way.
Caching is more like, hey, multiple things are going to need this thing, like, don't redo things. Now, your first gut reaction would be...
Don't redo things here.
Multiple things are going to need this thing, like, don't redo things.
Okay. So multiple things are gonna need this. Okay. So the TLDR is multiple things are gonna need this. Okay. Yeah, multiple things are gonna need this, right? Don't redo things. Don't redo things. What redo means? Oh, okay. Okay, multiple things are gonna need this. Don't redo things. That is the catching here.
Now, your first gut reaction would be, we should cache node modules. Can someone read my own notes to me about what npm-ci does again?
It deletes node modules.
Deletes node modules on every run. So we could cache node modules to delete it on every run as some kind of like, like we hate ourselves kind of thing. The other thing that we can do is, I'm using npm as somebody, and this is useful for anyone on the live stream, someone mentioned earlier that there were some issues using pnpm. There are alternatives to npm. pnpm, I don't even know what the P stands for, which is what I use. Yarn, so on and so forth. And for a while, it's one of those like cat and mouse games, which is Yarn was better than npm because it did a whole bunch of these different things that then npm just did, right? And so pnpm, which I have never said out loud until now and hate saying, Yarn, npm all have this idea of also they have a cache, right? And this is super useful because, like, let's say you are the kind of person who, before they moved all these exercises into one repo, maybe did the thing I do for a lot of the other workshops, which is make like 1,000 repos and make you clone an npm install. Even that's wasteful on your own computer, versus if you already downloaded for one, if it's the same version with the same hash, then you should be able to just use those same ones. So all of these have a cache file stored on your machine where they cache the dependencies that you've downloaded, right? What we could do in our build process is cache that, which is we'll still do an npm-ci.
Used to add a list or clean the npm cache folder. It's like, hey, this is the only package that, okay, this is all the package that I want to catch here. And this command is unaware of workspace. npm store catch data in an opaque directory within the configure catch. And catch. This directory is catch base content addressable catch that store all the HTTP request data as well as other package related data. This directory is primarily accessed through pacote. What the French stuff?
Pacote.
Pacote. A package. Okay. Pacote. Pacote. Okay. You sound like more like Italian, but in any case. Okay, pacote. Okay. Pacote. From npm. Okay. Oh my god. Fetch package manifests and tarbals from the npm register. Okay. It gets the manifests and the tarbals, which is a way of how you can compress libraries to send out, to stream over the cable, okay, from the npm registry. Pacote. This is one of the core libraries. Pacote works with any kind of package specified that npm can install. If you can pass it to the npm CLI, right, you can pass it to Pacote. In fact, that's exactly what the npm CLI does. Okay, anything that can do with one kind of package can do with when was the last time? Last month. Okay, so Pacote, oh my god, here we go. All right. So this is okay. We're talking about catching workflows, and then we go down to catching npm models. Okay. So npm store catch data in an opaque directory within the configure catch. Name catch underscore catch. This directory is the catch base context address. Catch is a Node.js library for managing local key and content address catch. When you talk about is this, show me a visual representation of this, right? When you say, for example, claw, right? Claw. What is a exactly? So what is catch in Node.js? What is a managing local key and context address? Create a visualization. Exactly. Create a visualization of it. Catch architecture and data flow. Okay. That's exactly what I want to do. Okay, so Node.js application is say, hey, I'm going to write this key and data So first I'm going to generate is a hash based on this, and this is a hash, which is just a function that actually is given the same input, you're going to generate a same output, right? In this hash, you cannot is exactly. Subgraph. Okay, different inputs, right? It say, hey, I'm going to convert this content into a fixed length hash, whether it's this or this or this, and it is deterministic, which is giving the same input, you're gonna get the same hash. And the properties of this is that it is unique, different input, different hash, fixed length, any input side has the same length, and this is one way, so you cannot reverse a hash content. So the uses of this hash is that allows to uniquely identify them, enables the duplication, same content and same hash. Exactly. Verify data integrity and provide efficient store organization. So this is a hash, right? This is what a hash is. It's just a function that given this particular input, it generates is the same output. Why do we want to do this? First, because it's deterministic. We can specify is the length of this. We can use this as a token for something that is unique. And one of the trade-off of this is only is one way. So you can, from this hash, figuring out is the input, right? Okay, because it's a function, it's a mathematical function for do that. So because now, we take a look at this. Because now, Catch is a sophisticated caching library for Node.js that implements a content addressable storage system. Content addressable store system. Hey, this address here, this space here, that I'm going to put this content, I want to now create a system to store this. So this is now the catch store, where they say, hey, I'm gonna create now an index that will contain is the content. This is the content store, content addressable store, where first you say, hey, retrieve the content. Okay, content addressables. Okay, content addressable store. Okay. Hey, I want to write now. Oh my. Okay. So hey, I want to write, and this is the key, and this is the data. I'm going to generate is a hash that is will be associated to this content that will be associated with this reference in memory, to this address in memory. Is catch is a content addressable storage. It's a content addressable storage similar to DNS. Well, CAS and DNS, content addressable storage and DNS share some conceptual similarities. They serve different purpose and work different. Of course. Similarities. Both are lookup systems. Both map identifiers to resource. Exactly. Identifiers to resource. And both provide a level of indirection. Both can catch results. The key difference is that this is interesting. It is quite similar, okay? There are the similarities, but both of them serve to a different purpose. But both of them are lookup systems. Okay. Sistemas de búsqueda. Lookup systems. Both maps, identifiers, and resources, and both provide a level of indirection. Interesting. When we talk about this content addressable memory, okay, that store all the HTTP request data as well as other package related. So this is the HTTP request, okay, and this is the package related to this. This directory is primarily accessed through pacot. Okay, so the way how they access through that is on that. But this is to manage. Okay, cache is for managing local key and content addressable cache. It's really fast, really good at concurrency, and will never give you corrupted data. Even if cache fails, get corrupted or manipulated. On systems that support user and group setting of files, cache will match the UID, this universal identifier, or this global identifier values to the folder where the cache lives, even when running as root. It was created to be used as npm local cache, but can just as easily to be used on its own. So this is when you can now tell to cache, hey, I want you to is catch this. Okay. I want you to now catch this. This is the catch path. Okay, and the destination here. So now if you want to actually consume that, the catch path and the key, once you get that, once you identify that content addressable, now I want to get this. Create writable string, which is this destination. Okay. The same thing, but skip the key index here. Get by digest is this. All right, this is something interesting that is doing behind the scenes. npm catch. Okay. So this directory is primarily accessed through pacot, the library responsible for all package fetching as the npm 5. Interesting. All data that pass through the catch is fully verified for integrity on both insertion and extraction. Catch corruption will either trigger an error or signal to pacot, which will do automatically. Okay, we'll refetch that. For this reason, it should never be necessary to clear the cache for any reason other than reclaiming this space. Thus, white clean now requires force to run. Okay, if you want to claim space in memory, or if you want to reclaim disk space, yes, you can delete the cache. But for any other use cases, does not, because they actually now handle that for you. There is currently no method exposed through the npm inspect to directly manage the counting of this cache in order to access to it. A cache must be used directly. npm will not remove data by itself. The cache will grow as new packages are installed. Exactly. So, not only that, okay, just about npm CI is this one, or clean install. This command is similar to npm install, except that it means to be used in an automated environment such as test platform, continuous integrations, and deployment, or any situation where you want to make sure you are doing a clean install of your dependencies. So the main difference between npm install and CI are the project must have an existing packet log JSON if the dependency in the package log does not match those in the package JSON, npm will exit with an error instead of updating the package log. If they are different, they're going to throw an error. It won't update that. npm CI can only install entire projects at a time. Individual dependency cannot be added with this command. Of course, if a node model is already present, it will automatically remove before npm CI begins to install. It's exactly. So it will never write to package JSON or any of the package log. Install are essentially frozen. Exactly. The problem is this. If a node.js is already present, it will automatically remove before npm CI begins install. It will never write the package.json or any other package log. Install are essentially frozen. So
We'll still set up node modules, but instead of reaching out to the network, we're just going to run on a local cache. Now, these are fresh machines every time, so we...
exactly. So, exactly. Okay.
We need to do something. We'll still do an npm CI. We'll still set up node modules, but instead of reaching out to the network, we're just going to run on a local cache. Now, these are fresh machines every time, so we need to do something. But we have that great segue that says that there is an action. There's an action for that, as they say. So let's go take a look.
Exactly.
There's an action. Instead of reaching out to the network, we're just going to run on a local cache. Now, these are fresh machines every time.
Exactly. Look at this. Look at this. Node or npm catching. npm catching. Okay, npm catching. Since running the CI, since running npm CI, okay, so since running the npm CI is a way of how do we set up things from the scratch, from the scratch. It's a way of how do we, it's a way to set up, it's a way to set up things from the scratch in continuous environments, okay? In automated environment, exactly. In automated environment, such as a testing environment, right? Test platform continuous integration and deployment, such as test platform continuous integration, okay, such as test platform continuous integration and deployment, okay. Here we have is AWS, Azure, that kind of thing, okay. Since the npm CI is a way how to set up things from scratch in automated environments, okay, and and because if this detect a node models folder, okay, if a node model is already present, it will automatically remove before the npm CI begins, right? So because this detects a Node.js model folder, because if this detects a Node.js model folders, it will delete it before the npm CI start. Okay. So
that. A cache file computer versus if you already downloaded for one, if it's the same version with the same hash, then you suppose I make you clone and npm install. The kind of person who, before they moved all the exercises into one repo, maybe did the thing have a cache, right? And this is super useful because, like, let's say you are the kind of person who, before they moved all the exercises into one repo, maybe did the thing I do for a lot of the other workshops, which is make like 1,000 repos and make you clone and npm install. Even that's wasteful on your own computer versus if you already downloaded for one, if it's the same version with the same hash, then you should be able to just use that same one. So all of these have a cache file stored on your machine where they cache the dependencies that you've downloaded, right? What we could do in our build process is cache that, which is we'll still do an npm CI, we'll still set up node modules, but instead of reaching out to the network, we're just going to run on a local cache. Now, these are fresh machines every time, cache that, which is we'll still do an npm CI, we'll still and for a while, our alternatives to npm, on the live stream, someone mentioned earlier that there were some issues using pnpm. There are alternatives to npm, pnpm. I don't even know what the P stands for, which is what I use. Yarn, so on and so forth. And for a while, it's one of those like cat and mouse games, which is Yarn was better than npm because it did a whole bunch of these different things that then npm just did, right? And so pnpm, which I have never said out loud until now and hate saying, Yarn, npm all have this idea of also they have a cache, right? And this is super useful because, like, let's say you are the kind of person who, before they moved all the exercises into one repo, maybe did the thing I do for a lot of the other workshops, which is make like 1,000 repos and make you clone and npm install. Even that's wasteful on your own computer versus if you already downloaded for one, if it's the same version with the same hash, then you should be able to just use that same one. So all of these have a cache file stored on your machine where they cache the dependencies that you've downloaded, right? What we could do in our build process is cache that, which is we'll still do.
Exactly. So, because now okay. So because now to speed up the dev, to speed up the build process, or to speed up the installation process, so we, instead of calling registers in the network, okay, we can instead of calling register in the network, catch them locally and access when you need it. So that's exactly what we need to do in our build or test CI process, right? And the reason is there is two ways of doing that. The general way, which is this, which is actually using is that particularly
Do an npm CI, we'll still set up node modules, but instead of reaching out to the network, we're just going to run on a local cache. Now,
exactly. So the idea here is this, because now to speed up the installation process, we, instead of calling
could do in our build process is cache that, which is we'll still do an npm CI, we'll still set up node modules, but instead of reaching out.
Exactly. So we instead of reaching out of the network, okay. So instead of reaching out to the network, instead of reaching out to the network, we catch that. We just gonna run a local catch. We are just gonna run a local catch. And access when you need it. And that's exactly what we need to do in our build or test CI/CD process. And this is the reason that, yes, the npm CI/CD server needs to run. You need to download all of these things, but instead of reaching out of the network, we're just gonna run a local catch for that. Okay, which is something that I'm doing with this CI/CD process. So instead of actually reaching all of these assets out of the network, we're just gonna run local catch for that. And when those catch change, okay, we're going to update this with a new catch. Am I right? Workflows run cannot restore catch created for child branches or sibling branches. Workflows runs cannot restore catch created for child branches or sibling branches. For example, a catch created for the child feature B branch will not accessible to a workflow run trigger on the pattern main. Interesting. Similarly, a catch created for the feature A branch with the base main would not accessible to its sibling feature C branch with the same with the base main. Workflows run also cannot create catch created for different tag names. For example, a catch created for the tag release A will with the base main would not be accessible to workflow run trigger to the tag release B with the base main. So these catch are feature independent, are branch independent. When a catch is created by a workflow run trigger on a pull request, the catch is created for the merge. Because of this, the catch will have a limited scope and can only be restored by reruns of the pull request. It cannot be restored by the base branch or other pull requests targeting that branch base. Multiple workflows running in a repository can share catch, and a catch created for a branch in a workflow run can be accessed and restored from another workflow run on the same repository on branch. So this is part of the restriction of this. Access restriction provide catch isolation and security by creating a logical boundary between different branches or tags. Workflows runs can restore catch created in either the current branch or the default branch. Exactly. So workflow run can restore catch created in either the current branch or the default branch, usually main. If a workflow run is triggered for a pull request, it can also restore catch created in the base branch, including base branch or fork repository. For example, if a branch feature B has the base branch feature A workflow run trigger on the pull request will have access to catch created in the main branch, the base feature A, and the current feature B branch. Okay. Okay, this is one of the restrictions here. Exactly. Restriction. Restriction. Cats are not available among siblings. Interesting. Okay.
For that, as they say. So let's go take a look. Caching. That looks like a good file to open up. Sweet. And so there. That's the long sheet answer. Let's look at the short version with these little eyeballs, which is we can add an additional step. And the reason we're going to do this the long way, and then I'll show you the short way, is that there is a shorthand for doing this that's way easier, but it only works in the very specific use case we're talking about. This way will work for everything.
Exactly.
So it is worth looking at both, the one that you could use for other things that are not NPM, and the one that you can use more generally. So other things, if you just want inspiration of where you can use this, is NPM comes free with Node. So set up Node installs NPM. The act of installing PNPM, if that's what you use, is a thing you might want to hold on to, right? And I don't do this because there's nuances around it. The open source project I work on, we do have a CLI binary that actually has a full version of the server baked into it in beta. I don't cache it because I'm too lazy to figure out how to check to have the most recent version. I could, because it's tricky. I could totally do it if I sat down one afternoon to do it, I just haven't. But I might want to store that version of the CLI because we don't change it that often. We change it like once a month or something like that. And so there's all sorts of things I might want to cache between runs, and so this action will do it. All right, so let's talk about what it is. So uses, which is just like where is this thing located, which is action/cache at v3. Those are kind of like in your package JSON. They are locked so that if somebody updates an action with malicious code, you have to go and bump your version to opt into that malicious code, or breaking changes, or malicious code. So actions/cache, that's like the repo name at v3. An ID, that's just some identifier. And then there's with, which takes two things: a path, like what are you trying to cache? That .npm directory is where npm puts its cache files. Right, so everything you downloaded, you hold on to, that's the path that we want to cache and save between runs. And the last one is what is the key, right? And so this is like how to check if we should read from the cache at all. And you can be really nuanced with this. You could have for instance, this repo, to my knowledge, does not have any compiled assets, right? I'm looking at you like Node SAS, right? Or if you're building an Electron app, like something where they're compiled for that operating system and architecture, right? Then you might want to also toss in, this is obviously the markdown file, you might toss in runner.os, right? So now it'll be, okay, we're storing npm caches for Windows. We'll talk about the last part in a second, right? Whatever unique identifiers that you need. You might want it for given, if you have a weird, if you have, when I say weird, if you have any kind of branching strategy to speak of whatsoever, you might use that somehow in here as well. I don't. The more important part is this piece right here. So this is how you do string interpolation. This is a function just provided by GitHub Actions for you, which is cool. Go find the package lock.json, which we know can't change when we're using npm CI, and just create a checksum hash, right? If the package lock has not changed, use the cache. If the package lock has changed, which means the dependency have changed, don't use the cache, right? But then that will be a new key, and we'll just get a new cache, right? So basically, the first job that ever comes across this will check to see, hey, do we have a cache key with npm dash whatever the unique identifier?
But instead of actually reaching out of the network,
cool.
let's
Load up that cache
gonna run or local.
Go
Exactly.
ahead and
We're just gonna run a local
and
caching access when access.
create it at the very end. We'll look at the pre and post to see this all happen. But that's kind of the kind of high level piece. So we cache it, and there it is now. Fun fact that if you edit your YAML in a markdown file for your notes, that does not necessarily change your code. I know this because I used to teach for a living, and you knew it was time to stop when you were editing the markdown file with the code instead of the actual code, and refreshing your browser and wondering why it didn't work.
What are the dashes? Is that just like a semicolon sort of thing?
These dashes?
Yeah.
These are separating each, name and uses. This is two properties on the same object.
Oh, okay.
It's a syntax for YAML.
Yeah.
Okay. That was also a question in the chat. There's also the edit. So I noticed name can be the first property, but name is also followed like a run command. It's that same thing.
The properties can be in any order.
Yeah.
It's kind of like keys on an object in JavaScript.
Sure. So a dash.
Interesting.
Declaring a new object.
Yeah. It's like a comma. It's basically.
Irreducible network calls.
YAML seeks to be.
Irreducible network calls.
Sometimes guilty of being a little bit too clever by half.
Exactly.
But also I am from the era where I had to write
Because
comments,
it's reducing network calls.
Sweet. And you can put these in any order if you want to do uses and then name. I can even do
Okay, that makes a lot of
really hate
sense.
myself. And just so we can see it later, what emojis do we like to use? My new favorite is this one.
Catching dependency in GitHub Action can
And I'm mostly putting
significantly
that so we
speed
can
up the
see it.
workflow by avoiding
some way to like,
repetitive
because we're checking out
downloads.
repository, that could be anywhere.
Exactly.
Cool. And so we will also. Oh, I didn't put.
That's
I talked a lot about
interesting.
caching. I didn't like put it in. Cool. And we gotta get the indentation is important.
But is this?
YAML. So it's like Python too. How many like languages can I smack talk
Exactly.
at the same time? Let's find out.
But it's this. It's like catching
Developer, so I have no
catching
right
dependencies.
to say anything. And let's actually do this across the two.
Dependencies.
So the first time they're both gonna make a run at it.
GitHub Action in
unintended,
GitHub Actions.
which is because like the cache will be empty for both of them when they start in parallel.
Thus,
but then the next
the
time, one of them will fail
or
writing to the cache, but that's okay.
avoid
Because the reason it will fail writing to the
the
cache is because it already
need
did it, right?
to
which is also like, if you mess this up, just do
repeat
npm
it,
dash,
repeat
you're gonna have to go in there and
it.
manually fix it. And we'll talk about how.
Download.
So we'll add in those two caches.
Exactly.
And
So catching
let's go
dependency in
ahead
GitHub
and
Actions,
say,
avoid the need to repeat
add
it.
cache in
Downloads,
to workflow, push it up.
which speed up.
Command-Shift-G again to open yet another tab,
Exactly.
even
Which
though I totally like just command-tabbed over.
speed up.
And let's
speed
take
up.
a look at what we got.
Which speed up
All right, starting the
workflow.
job, setting up the job. You can see there's my happy
Workflows
checkout
execution.
repository right there with my emoji.
That's what it is.
Thing that I might be
That's
doing when I get back to
exactly
work
what
next
it's doing.
week
So
is
catching
putting emoji
dependency in GitHub's
stats.
avoids the need
There's
to
nothing better- no better way to set back
repeated
than
downloads,
causing
which
chaos.
speed up the workflows,
You can
which
also
speed
nice
up
because
the
you can see what
workflow's
the post is as well.
execution.
I kind of like it actually. Like I put the emoji in there as a joke,
Interesting.
and I think I'm into it because it makes it very clear where the start and end of each one is. So, pro tip that is hot off the presses: emojis work in your job names and can be useful. You can see set up nodes kind of in the middle there, like they do the post in the opposite order that they came in. Cool. And so also like if you look like setup job is like lowercase.
So avoid the
but then
need to
post,
repeated downloads, which
then
speed
like,
up
I don't know how to handle
workflows
consistent
execution.
capitalization in these things, so do whatever
That's
you
the
want.
goal of this. It's like, hey,
Cool, so we run npm
avoid the
check, run
time
npm
that
test
it
in this
takes
case,
to actually
post setup node,
execute this
actually run
workflow
post cache.
by
Failed
catching
to save.
stuff here.
It did fail to save. You know, luckily the
All right.
good on this one. Other than the giant is all 16-second self by hitting and start purging stuff. And I think also unless main has it for almost no work. And this is a small app. 2 something playwright download.
So that'll be all for this video. Take care. Bye bye.